Planning and implementing file and storage services. Windows Server got its start really as a departmental file server, and being a file server and providing file services to the network is still one of the most important things it does. So we're going to look at a lot of the new features that are available in Windows Server 2012 to help make that happen. We'll start this nugget with a look at storage pools and spaces. We'll also be talking about some of the different storage area network options you've got to work with, including iSCSI, Fiber Channel, and Virtual FC. Really important if you're going to have virtual machines talking to a Fiber Channel SAN. We'll also be talking about some iSCSI target server functionality, the Internet Server Name Service, and the Network File services, all different services that come with Windows Server 2012. Most of what you'll need to know will be covered in this nugget, but there's a couple places you can go to learn a little bit more about some of these topics. For example, in the CBT Nuggets series on exam 7410, you can learn more about designing and managing storage spaces and pools. We're going to kind of start by assuming they're already set up and talk about some of how they work and some of the different decisions you'll make. In the series on exam 7412, you can learn a little bit more about thick and thin provisioning, a couple of topics that we'll be discussing during this nugget. Storage spaces and storage pools is one of the exciting new features in Windows Server 2012 that essentially lets your Windows Server become a sort of storage area network, kind of. It's a way to use cheap, inexpensive disks, JBODs, just a bunch of disks, in an effective way to create large and extremely flexible storage areas. So here's where it begins. You start with one or more physical disks, and these need to be greater than 10 gigabytes. So they need to be at least 10 gigs. But I doubt you have any old 10 gig drives laying around. You pull in as many of these as you want to, and you can attach them pretty much any way you want to. They could be external USB drives or I guess even FireWire, SATA drives, so serial ATA, SAS, serial attached SCSI drives. They could even be virtual hard disk files, VHD or VHDX files. You pull them all together into a storage pool. Now you'll notice that I've got a little different color scheme going on here. Each of these blue ones is intended as a primary. This guy I set up as a hot spare, meaning if one of the primaries takes over, he can jump in and take over for that. Now this isn't quite mirroring or RAID at this level. The designation of a hot spare doesn't automatically cause data to be mirrored over to there. It just designates it as a hot spare. That actually gets utilized at the storage space level. So here's what I've done. I've got a 2, 4, 6, 8, 10 gigaterabyte storage pool, keeping in mind that my hot spare over here isn't being actively used. Now I can start carving that storage pool up into storage spaces. And that's what these guys are, the blue boxes. This first one has been named home data, so each storage space has a name. It has a size. This one's 8 terabytes. It has a recovery mode as well as a provisioning mode. Now, thin provisioning means that this storage space won't actually occupy 8 terabytes. The storage space will dynamically grow and will physically consume space as it needs to. That's in contrast with thick provisioning, which means this one is going to physically take up 2 terabytes of space out of the storage pool right off the bat. Now, if you were good at math, let's see, 8, 9, 10, 11, 12, 13, 14. I've got 14 terabytes of space that I've promised, but only 2, 4, 6, 8 terabytes of active available space. You might wonder what's going on there, and I'll tell you in just a sec. But there's one more thing we need to focus on first, and that's the recovery mode. And your options are parity, mirrored, and simple. Simple means that your data is not safe. It's not backed up. If you lose any of these underlying drives, any simple space could be affected and you could lose data. Now, if this particular space managed to carve out all of its assets from this one physical hard drive and this drive failed, then all of this would still be safe, but you don't know that's what's going to happen. You don't really have that kind of control over it. This one is mirrored. That means all the data is going to be stored on at least 2 physical devices in the underlying storage pool, and that's why we designated a hot spare. So if this one is carving its data off of this drive, and this one fails, then this one will still have a backup, and it can grab this and start mirroring the data over to it using that hot spare. Your third option is parity. And that is essentially the same technology that was used by a RAID array, redundant array of inexpensive disks, meaning your data has a primary storage location, but it's actually got parity information stored somewhere else. So if this is lost, the hot spare can come into play, or some available space on another one of these physical devices could come into play, and the parity information will be used to reconstruct the missing data. Now let's get back to that idea of over-provisioning, because that's really what I've done here by committing all of this space without actually backing it up with enough physical disks to fulfill that. And it's because you can always come to a storage pool later and add more disk devices. So even though I've significantly overcommitted now, that doesn't have to be an overcommitment later when I actually start using some of this, because remember, it's thin provisioned. I'm not actually using it until I need it. Once I start using all that data and my physical devices start to kind of fill up, I can just add more devices, and I don't need to re-provision any of the spaces. Now, on top of a space, once you've created it, you then create a virtual disk, which can be exposed to the machine as a volume, like I've done here. So just like any other disk, really, at that point. But instead of taking it from a single disk, it's spreading it out across all these things. So it's a pretty neat set of technologies. Here in Storage Manager, I can show you what it looks like. We'll pop over to the server's File and Storage Services. We'll start at the bottom level with a storage pool. Now, you can see that I've got a primordial storage space, and that's the actual set of available disks that have been plugged in, and you can't use that directly. What I've done instead is built a user data storage space. That's what I named it, user data. So this is a storage pool that is built on top of those physical disks. This particular one has a roughly 34 gigabyte capacity, and there's about 31 gigs free. So what have I done with that? Well, on top of that, I built this virtual disk. Let's take a look at its properties. It's called Homes. It's 10 gigabytes in capacity. Only 2 is used so far, which means it's only used 2 out of the pool space because it is thin provisioned. It's in good health. This is a simple layout. It is physically using disk 1 and 2 out of my 3-disk pool, and I don't have any other, it's read-write access. So that's kind of neat. And on the pool side, let's take a look at this pool's properties. So we built that on top of that space. This is called user data. Again, it is using the storage spaces subsystem. It's used roughly 2 3/4 gigabytes of the 31 that's available to it. It's happy and operational, and I can look at a few different properties of that pool. So the pool has been built on top of this primordial space. I've built a disk on top of that, and I can use it just like I would any other disk space anywhere on the server. Now let's go back and create a new one here. We'll create a new virtual disk. New virtual disk wizard. I'm going to create this from that user data storage pool, which has got roughly 31 gigs free. Let's call this one app data. What do I want my layout to be? What's my recovery mode? I chose simple before, but if I mirror it, I'll have the data duplicated on at least 2 disks, possibly 3. It does reduce the capacity in the pool because you're duplicating your data, but it helps ensure that the data is more reliable. In parity, you're actually striping the information across physical disks. Again, losing capacity. And your storage layout needs at least 3 physical disks in the underlying pool, in the underlying space. So let's just leave it at mirror. And I'm going to thin provision this, which means it's not going to use all the space right away, but I will allow it to use up to 10 gigabytes. And that looks like it's all good. Let's create that. Now, it can't actually be used until you create it as a volume. So there's a little checkbox down here to launch the new volume wizard. And it'll sort of pre-populate it with that thing. So there's the virtual disk that was created. We'll click next. I'm going to create a volume using all that space. I said 10, but you lose a little bit due to the formatting. We'll assign it a drive letter, format it as NTFS. Let's call this, give it a nice volume name. I am going to turn on data deduplication. And what that's going to do is attempt to look at, in this case, all files that are older than 5 days. It's going to do this more or less continually in the background, but it'll do it at a low priority. So if the system is really busy, it'll stop trying to deduplicate. And that way I don't have to set a schedule. If you find that that's not working for you on a performance basis, you can turn off background optimization and instead have it run on a specific schedule. We'll just leave it on background for right now. So what this is going to do is try and go through and find duplicated data. And rather than keeping multiple copies of that data, it's just going to keep one copy and then pointers to that. So if I had 3 files that were all essentially the same, it would keep one of them and then keep pointers to it. That can be great on folders, on volumes like where you keep your user home drives. Because if there several users are keeping copies of the same thing, under the hood, you can just keep one copy, but they'll all think they have their own. Now, if one of them opens it and makes some edits to it, thereby creating a different version of the file, then that will split off and become its own standalone file. So you don't have to worry about sharing or are people going to be walking on each other's edits or anything like that. You don't have to worry about that. You can also exclude specific file types. You know, if you find you're having problems with it, you can say, I want to exclude MP3s from this. So it looks like everything's correct there. This will take just a moment to format and mount and good. And now I should be able to open up Explorer and on my computer see my new F drive, AppDara, typo. So it's pretty neat stuff. It's pretty straightforward. Now, one of the cool things I mentioned was if we go back to, here we go, my storage pool up top. At some point, if I keep building this out and I keep adding these little 10 gig chunks, my 30 gigs is going to be overcommitted. Because remember, I thin provisioned these things. They're not actually taking up much space. Right now, out of the 38.8 gigabyte capacity of the pool, they're only taking up 3, but they'll take up to 20. So at some point, I need to add a physical disk. And I do happen to have another 12 gig disk in here that's not being used for anything. I'm going to allow it to be automatically utilized. I'm not going to designate it as a hot spare. And that's going to take a little second to run through. And all right, looks like it's done. Yep, my capacity is up to 45 now. So let's take a look at the properties of that. And yep, looks like it bumped everything up. And you can see when I click on this that my physical disks down here are listed. 1, 2, and 4, which I just added, are automatic utilization. And 3 was designated as a hot spare earlier. So if you scroll down and you can scroll over, and depending on the type of disk, you might see the type of chassis and its rotational speed and everything else, if that information is being communicated to Windows. So this is kind of a really cool way to flexibly use your storage, to allow people to use a lot of storage, but not necessarily give it to them up front. You can buy it kind of on an as-needed basis and be very flexible and very dynamic about the whole thing. Now, many organizations these days don't rely on having just a bunch of disks plugged into their servers for storage. Instead, they use a storage area network. With a SAN, you really take one giant box. I mean, we're talking a rack full of hard drives, and you carve it up into hunks, and you assign those hunks to different servers on your network. Not totally unlike how storage spaces and pools work, conceptually at least. You're taking a giant hunk of storage and carving it up for specific uses. The difference is that the storage area network isn't a file server. It doesn't allow people to get in and open files. Instead, it acts as a remote disk. In fact, you've really got 2 popular SAN protocols these days. One of them, iSCSI, is notable because it runs the same SCSI protocol that you would run if you had just a bunch of SCSI disks physically plugged into your computer. The only difference is that they can be separated by a greater distance because they're running over plain old Ethernet. So it takes that block level access, it's called, that block level storage protocol, and puts it on a normal Ethernet connection. Now, folks have really started liking iSCSI these days because it does use normal Ethernet, which is inexpensive cabling, inexpensive switches, inexpensive infrastructure in general. Also quite fast. Ethernet's pushing up toward 100 gigabit and beyond these days. And so people are really kind of getting into that. Windows Server 2012, as you'll see a little bit later in this nugget, provides a pretty significant amount of support for iSCSI, meaning it's even easier to use that out of the box. The other option is called Fiber Channel, and it can run over, it's a protocol. It's a protocol. It can technically run over copper cabling or fiber optic, but it gets its name from fiber optic. And the neat thing about fiber optic is it can run very long distances. It's almost impervious to noise. In other words, if you accidentally drape a cable across a fluorescent lighting fixture in the ceiling, it's not going to affect it at all because it's not picking up any of that electromagnetic stuff. It's using fiber optics instead. FC is more expensive. I mean, you've got to have specialized FC infrastructure, all that specialized expensive fiber optic cabling, everything else. Now, in terms of the components, your SAN has to speak whatever protocol you want to use, so fiber channel or iSCSI. You have to have the appropriate cabling between the SAN and your servers. So that's often fiber optic in an FC installation. Could be FC over copper. Ethernet in an iSCSI installation. And then you have to have something for that cabling to plug into on the server. In the case of iSCSI, that would simply be an Ethernet adapter, which might already be built into the server. In the case of fiber channel, it's going to be a host bus adapter, which is really just a specialized network adapter used for fiber channel. It's the fiber channel version of an Ethernet network card. So that's all. But it is one of the things that makes fiber channel a little bit more expensive is you have to have a little bit more specialized hardware. Now, in some cases, you've got an option to do something slightly different. We talked about Windows storage spaces and storage pools, which let you carve up storage, but they're really intended to provide file-level access to that storage, not the block-level access that a SAN does. However, there's a new protocol, a new file sharing protocol in Windows Server 2012 called Server Message Blocks 3.0. Now, SMB is what we've always used for doing file share and stuff like that. The difference now is that SMB supports file storage virtualization for Hyper-V, meaning if this is my Hyper-V host machine right here, I can actually keep all of its files on basically a file server. And I could have that file server space provisioned using storage spaces and pools, and it can talk SMB. And we're talking iSCSI level of performance here. So this is really a viable alternative to an inexpensive kind of storage area network-ish thing. It's not exactly the same as a SAN, but it meets a lot of the same business needs. In addition to Hyper-V supporting that, Microsoft SQL Server also supports accessing its database files across SMB file shares. And that works in SQL Server 2008, R2, and later. And then upcoming versions, so up-level versions, we're talking SQL Server 2012, also support that for clustered SQL servers. So SMB 3.0, combined with storage spaces and storage pools, starts to give you SAN-like options that are less expensive because there's no specialized architecture, and you don't have to have a giant SAN box. You can just have a Windows server with just a bunch of disks plugged into it, divvied up using storage spaces and storage pools. It's not going to meet every single need that a SAN does today, but it does meet some needs, and it meets them in many cases less expensively than a traditional SAN might. Now, speaking of SANs, and particularly virtualization, I want to talk about something called Virtual Fiber Channel, which is a feature of the Hyper-V hypervisor in Windows Server 2012. Let's start by talking about how this type of thing normally works. This will be over on this side here. You have a virtualization host. Okay, that's this. And it has a host bus adapter plugged into it, and that allows it to talk to your storage area network, your fiber channel storage area network. You set up a virtual machine. You create one or more virtual disks. But those disks aren't physically being stored on the virtualization host. You see, every time the virtual machine's operating system needs to write to disk, it gives an instruction, essentially, to the hypervisor, which then has to parse that across the network through the host bus adapter, and the virtual disk file is physically located on the SAN. This can create some performance issues. It's a lot of layers of things. You've got to go from here to here to here to here, and there's just a lot of things that have to get involved. Predominantly, the virtualization software, the hypervisor, Windows Server itself, has to become involved in every single disk operation. Now, that's because the virtual machine says, okay, I'm going to save something to disk. And the hypervisor have to say, oh, sure, but you don't have a disk. So I'm going to intercept that and direct it out through my host bus adapter off to the SAN. And that's where I'm going to create a file to hold all of your data. So if you think about it, every single time the virtual machine needs to write something to disk to save some data, it's two separate write operations. One from the virtual machine to the hypervisor and another from the hypervisor to the SAN. Not very efficient. So one of the new features in Windows Server 2012 is Virtual Fiber Channel. What it basically does is it creates a virtual HBA inside the virtual machine that is linked to the host's HBA, which in turn talks to the storage area network. So what that means is when the operating system inside the virtual machine needs to write to disk, it's one smooth operation because it is talking directly to the host's HBA. So it is able to see the SAN as a SAN. It's able to write directly to the SAN without the hypervisor having to get involved in the conversation. So it's just one write operation instead of two. That's a pretty significant feature, and it can, depending on the application, create some pretty significant performance benefits. So it's worth keeping that in mind as you design these types of architectures. Now, while I have this up, another feature of Hyper-V that you should be aware of when it comes to storage is a device-specific module, or DSM. Now, a DSM is provided by the vendor of your storage solution. So if you have a SAN made by Dell or by EMC or whoever makes it, they provide you with a Hyper-V DSM, and that gets installed inside the virtual machine. And it allows the virtual machine to optimize its communication with the storage system so that it communicates with the storage system in the way that the storage vendor most intended. So this is kind of a real performance boost if you happen to be using a storage system that supports a DSM. So again, they're made by the storage vendors, and it's used in conjunction with something called the Multipath I/O framework, which is a way of kind of interleaving input-output requests to a storage system and increasing storage throughput. So it works on top of that, and it helps ensure that your workloads are optimized by the storage vendor so that they can kind of leverage whatever unique, cool magic is going on inside their storage system. So just be aware that that exists. It is something that has to be installed. It's not magic, and it does have to be provided by the storage vendor. Now let's jump back to the topic of iSCSI, because I did say I was going to show you some of the built-in iSCSI stuff. And the first thing we'll talk about is the iSCSI target. So iSCSI consists of two pieces: the initiator, which creates a connection to an iSCSI storage repository, as well as an iSCSI target. And that's what receives the connection and actually makes the storage available to whatever server or client is trying to get to it. Now, Windows Server does come with an iSCSI initiator, and it allows the server to see iSCSI storage, and you can find it, here it is, on the Tools menu in Server Manager, iSCSI initiator. But it also comes with an iSCSI target. And this gives you another cool option for making an inexpensive storage area network. In other words, whatever storage happens to be attached to this server can be exposed as block level storage, just like a storage area network, to iSCSI initiators out on the network. So again, this is where storage spaces and storage pools can come into play, and you can create, and in fact, your own SAN really, if you want to. And if you're not in a giant organization and you kind of want that flexibility of being able to dynamically assign and expand storage, this is a good way to do it. So I'm going to briefly show you where the iSCSI target server is located. Now, this was something that was a separate download in older versions of Windows. These days, it's built in. You do install it. It is a feature that has to be installed. And once it's installed, you'll find it here under File and Storage, iSCSI. You can see here that I've already configured a target. So let's take a look at this, see what it looks like. Take a look at the properties. This is its virtual disk path. So this is the VHD file that is the, if you want to call it the disk drive that's being exposed. It's this large. I've only given it 2 gigabytes. It is a fixed drive. This is the iSCSI initiator address. So this is what an iSCSI initiator would launch off to get to there. No one's connected to it. And this particular one happens to be the C drive of a domain controller. It's got a serial number, a logical unit number, everything else. So creating one of these is relatively straightforward. Let's just run through the process. In fact, this will be even better now that I've gone ahead and set up my storage pools and spaces. So we'll create a new iSCSI virtual disk. That's what this is called. Let's see here. We are going to pick it off of the, let's grab that E drive I created. We'll give it a name. HomeDers. Give it a maximum amount of size to take up in that space. We'll just give it a couple of gigabytes to play with there. So what do we want to do? What target do we want to create for this? Well, let's give it a new target. And then we'll get to create a name for that target. My iSCSI new target. We can add iSCSI initiators that will be able to access it. Let's just query, I'll grab one of my servers. I have a server called member. We'll let him access it. There it is. There we go. And you'll see that what it's done is it's translated that into an actual IQN. We're going to talk a little bit more about those in just a second. So that's the server that's allowed to access this. I'm not going to enable any authentication. And just quickly review the details. Yep, that looks good. Create, cross our fingers, and boom. So now we have another virtual disk. So it's pretty cool stuff. You know, again, it's an inexpensive way of setting up something that has a lot of the advantages of a SAN. And you don't have to go buy really expensive SAN to set things up. It's a kind of a cool trick, especially for Hyper-V servers and SQL servers to use that way as well. Now, closely related to that is the ISNS, or Internet Storage Name Service, and it's designed for initiators who are looking for storage so that they can discover the storage that's available on the network and, if they're allowed to, connect to it. You can kind of think of ISNS, at least I do, as DNS for a storage area network. Now, it's not just iSCSI, although that's where you'll see it most commonly used. It automates discovery, management, and configuration of iSCSI and fiber channel devices. And fiber channel is done using a special gateway. ISNS really was kind of made first and foremost for iSCSI, but with an IFCP or fiber channel gateway, then you can pull it together. Now, that said, an important distinction here is that the Microsoft ISNS server, which I can get to here on the Tools menu, ISNS server, the Microsoft implementation of this thing only supports the discovery of iSCSI devices, not fiber channel devices. So it's a repository of all of your currently active iSCSI nodes, as well as their all their configuration information. A node can be an initiator, so something that wants to connect to storage, a target, something that is storage, or a management node, which is kind of a third party that keeps track of everything. Initiators and targets will usually register with this, and you would see them here. This is the list of registered things. So they would normally register with this, and initiators then query the server for a list of available targets. So there's a whole dynamic database that's built into this thing of all the iSCSI devices and all the related information that's on the network. It also provides state change notification. So clients, initiators can be told, hey, there's been a change in the database, and it allows a client to maintain a dynamic picture of the storage that's available on your network. And this other thing here, discovery domains, is cool. A discovery domain service allows an administrator to assign iSCSI nodes, so targets and initiators, into one or more groups, which are called discovery domains. And those kind of give you the ability to create zones. So if I'm an initiator and I'm in zone A, or discovery domain A, then I can only see the targets that are in my same zone, my same discovery domain. And this is pre-registered with a default DD. And we can create more. And they're just names. I'll call one my zone. And then you can see here I can add members to this. So I could add a target. Actually, I have a target here. So that's a target now. And that's now an initiator out on my network. And so those two would be able to see one another within this discovery domain. Those don't show up over here on this because they didn't automatically register themselves. So it's a pretty critical little thing to help make the management of an iSCSI network easier on you. So that ISNS server, like everything else on the server, is a separate service that has to be installed. In fact, I can show you where it is real quick. If you go into Add Roles and Features, pick your server. You'll find it under Storage, I believe. Yep, there we are. And actually, so it's in here. There's also the iSCSI target server and storage provider, but this is also where server for NFS lives, which is convenient because it's the next thing we're going to be talking about. NFS stands for Network File Service, and it's basically the same as Windows file sharing, but for Unix machines. So Windows machines, when talking to a Windows file server, uses a protocol called SMB, server message blocks. Unix servers use NFS, and Windows is capable of sharing a folder with Unix. So once you've installed that server for NFS feature, the way you play with it is just find a directory that you want to share, right-click it. Where's my right-click? There we go. Share with is not going to get it. You need to go all the way to Properties. Go to Sharing is your normal sharing tab, right? This is how you would share things as a shared folder with Windows clients, but now we've got another tab called NFS Sharing. So I can share this folder via NFS, set some authentication options, allow Kerberos privacy authentication, integrity. I do not want to allow no authentication, so I'll uncheck that. And then I can decide who's going to have access to this and what access they're going to have. Read, read only, read write, and so forth. So yeah, pretty straightforward little thing, just there so that Unix machines on your network have a way of getting to your Windows file servers without you having to install extra software on the Unix computers themselves. All right, that was quite a bit for file and storage services. Spent some time on storage pools and spaces. We also talked about data deduplication in there, some of the different provisioning models, and some of the different layout or recovery options that those things offer. We talked about some of the differences between your storage area network options, iSCSI, Fiber Channel, and the importance of virtual FC if you're going to have virtual machines talking to a SAN. Showed you how to set up the iSCSI target server and the ISNS service, and how to configure some of the options for the NFS service inside Windows Server 2012. I hope this has been informative for you, and I'd like to thank you for viewing.